Hello, I welcome you to this session of Python programming. In today's session, we'll be discussing about the decimal type in Python. So Python 2.4 introduced a new core numeric data type, the decimal object, formerly known as decimal. Now, syntactically, for you to use this decimals, you can import a module named decimal in which you can use a function decimal rather than running a literal expression like we do with the floating points. And functionally, decimals are like floating point numbers, but they have a fixed number of decimal points. Hence, decimals are fixed precision floating point values. So the usage of decimals is different syntactically. How you can use it, it is different from your float, but functionally it is like floating point, but with a fixed precision. Now, for example, with decimals, we can have a floating point value that always retains the number of decimal digits that we want. We'll see that in the examples that we carry out. Now, we can also specify how to round or truncate the extra decimal digits beyond the object's cutoff. Although this type of thing would generally, incur a performance penalty compared to the normal floating point type, the decimal type is well suited to represent fixed precision quantities like sums of money and can help you achieve better numeric accuracy. Now let's see how this could be useful. For example, consider the expression that is there on the screen, that is 0.1 plus 0.1 plus 0.1 minus 0.3. Ideally, when you run it, the result of this expression should be 0. But due to the difficulties and limitations in the representation of floating points, these numbers are not stored exactly as they appear to you. So to you it should be 0.3 minus 0.3, that is 0. But once you run it in the interpreter, the Python interpreter, you will get an output like this, which is very close to 0 but is not 0. Okay. So what you can do is you can use the decimal type in Python. Okay. And you can use this syntax to create decimals. So for example, this decimal in single quotes you pass a string 0.1, it would represent the floating 0.1, but with a better precision and better accuracy. Okay, so let me just start a Python session for you guys, and let me just write here. So to use this decimal, I need to import it from the decimal module. And then what we can do is we can simply copy this thing out here. But before that, let me just show you the output here with a normal floating point representation. So you see the answer should be 0, but it has not come as 0. Now if we represent the same thing with a decimal, okay, so for example, if I write decimal, say 0.1, say I want to represent this, so I can write it here as this. So if I print x, obviously it is printed as 0.1. So this decimal is equivalent to your floating point, but with a better accuracy and a better internal representation. So let me now just copy this. This is the same expression that I have written here, 0.1 plus 0.1 plus 0.1 minus 0.3. Okay. Now let's see the answer of this expression. Okay. So you can see the answer is decimal 0. So if I assign it to say some variable here, say t is equal to this, and if I print the value of t, it will come as 0.0 instead of this very small number 5.55 into 10 raised to power minus 17. Okay, so let's now get back to this presentation here. If whatever is the maximum number of decimals that I take in my query would be the output in the answer also. For example, here it is decimal 0.1, here it is decimal 0.10, and here it is decimal 0.10. So here we have two places of decimal, here two places and here one place. So answer instead of 0.0 now comes as 0.00. So we can just run this and see whether it behaves like the way we are thinking. Yes, so it is like this only. Okay, so that is all regarding the decimal type in Python, and you can just work around with the examples based on this, and wherever you need to carry out some efficient mathematical floating point computations, you can take the help of this decimal module and the decimal function. In my next lecture, I'll be discussing with you the fraction type in Python. Till then, goodbye. Thank you.